Okay, last but not least, we need to discuss how we use logarithms to solve exponential equations. So using logarithms, it's going to be a couple little properties, but this will be that last little piece that you hopefully been looking for, because you have been wondering how in the heck can I use my calculator for things other than base 10. You have the ln key for base e, you have the log key for base 10. Now, what about all those other ones? Because there's a lot more bases that aren't 10 and base e. And that's what today's explanation will be about. If we could pass these up for a second, because we'll do those in class, let's talk about this. If we want to solve equations of the form b to the x equals a, which is what all of our equations have been. So take a look at the example that I have here, b to the x equals a. When I say b to the x equals a, I'm looking at 3 is my base, x is the exponent, and it equals a number. And in most cases, you can do a problem like this in your head. 3 to the first, 3 to the second, not big enough. 3 to the third is 27. 3 to the fourth is 81. So I know that my exponent here has to be between 3 and 4. But I don't want to have to figure that by hand. We can't just hit a log button or anything like that. So here is what we need to do. We've broken you up into, we're going to break you up in two groups, and hopefully see that this is what works. So think of it as, and you're going to see me doing both, on the left side we have the people who like logs, and on the right side we have the people who like natural logs. And it really doesn't matter what your preference is. So if we said take the logarithm of both sides, here's an equation, 3x equals 57. If I asked you to take the logarithm of both sides, it's sort of like multiplying it, but it's not. You're just putting the logarithm in there so you can use it to help you. And that is the first step we need to do. So if I took the logarithm of both sides and I used the ln, it would look like this. If I used log, it would look like this. So you're seeing your exact same equation, 3 to the x equals 57. But in place, in front of each of those terms, you're seeing the log or the ln, natural log. Doesn't matter which one you use. So pick one and let's go with it, and let's go to step 2. Use the powering property. So right now you're noticing that everything is on the same level with the exception of this x. It's raised up. So if we use our power property that says if I'm an exponent in a log, I can come down as a multiplier. So if I come down as a multiplier, that's only going to change the left-hand side of both of these. All right. Now if everything is on the same level, the rule generally is solve and get x by itself. We've done that forever. So it looks like on this side we need to get rid of the log of 3, and most of us would divide because that's a multiplication problem. So if we divide by log of 3 on both sides, over here it's the natural log of 3 that we need to divide by. We're going to do a division problem and be able to cancel on the left-hand side. But on the right-hand side, we're still stuck, because stuck in that, no, we're not going to punch that in. We don't have a problem. But we do have the rule that says, oh, x equals the log of 57 divided by the log of 3. Those are both base 10 numbers. I can put that in. Over here, it's a natural log, and I could put that into my calculator. So those of you who are doing it in the common log form, log, divide. Those of you that were doing it in the natural log form, ln, divide. And let's see what happens. I do believe we got the same answer either way. So if this is a 3-step process, every time you see something that's not base E or base 10, and it really doesn't matter which you do, the log as in base 10 or the log as in base E, it doesn't matter because you got the same answer either way. You get to pick a choice. When does it matter? Well, obviously, if it's a base 10 problem, it makes sense to use log. As if it's a base E problem, then it makes sense to use natural log. So keep that in mind as you work, but if it's any of those other, base 5, base 2, base 7, it's all up to you. So knowing that, let's go ahead and try a couple. So this change of base formula is what we basically just used in our work, and it really meant that we take the log of that number that's sitting right here and divide it by the log of our base. And you can say, well, I really didn't recognize that, so let's go back. Okay, we can do that. What we did in the end here was take the log of that number and divide it by the log of the base. It did not matter whether it was ln or log. So follow that setup. If we can get any non-base 10, non-base E number into our calculator with that, then we're going to call this the change of base formula. And that's going to be a good thing, because a lot of your logs will now be able to be done with the help of a calculator. Not a single key, but a quick formula. So on this one, you should be thinking what? The log of 100 divided by the log of 4. Do your math. And since it was written in log, I just kept log. There's really no rhyme or reason there. And when you do your math, and we're rounding probably because these are going to be messy, did you get a 3.32-ish answer? Okay, ready for the next one. Log of 50 in base 2. Again, this is one you could do in your head. You know, you're saying, well, yeah, 2, but it doesn't work exactly. You know, you got 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth, 32. You know, we're there a while. 2 to the sixth, 64. Okay, so between 5 and 6. Just do the math. Change the base formula. Change the base formula says the log of your number divided by the log of your base. Do the math with your log key. Rounding. Did you get a 5.644-ish? We already had that figured out. What need to fall between, but now we're getting a better answer. Change the base formula. We're in base 3 this time. So the log of 50 divided by the log of 3. Rounding carefully. Hundreds, thousands, whatever the direction says. Apparently thousands. A real life problem. At what rate of interest, compounding continuously, would you have to invest your money so that it would quadruple in 25 years? Oh, okay, so we're doing money problem. Pert, nert, it says a couple things to highlight as you go through your problem. That we are compounding continuously. Would you have to invest your money so that it would quadruple in 35 years? All right. Or sorry, 35, 25. So if we start there, let's go with that pink. It'll probably show up okay on this. And we know we're doing continuous compounding, so A equals P E R to the T. So that our money would quadruple. So we're going to go with P as our original amount and 4P. That would be a quadrupled as our final amount. E is E. Our rate, we do not know, but we do know 25 years. So we're going to have R times 25, or if you like that better, 25R. Let's get rid of this P first, because you're supposed to have it by itself. And when we do, P is going to give us just that lonely old 4 over there. So 4 equals E to the 25R power. This is exactly what we said before. You have your unknown up in the exponent. You should be using what? Yes, your natural log formula. So I say natural log because we're in base C, so the next step would be take the ln of both sides, natural log. Keep in your exponent and everything there. Noticing that the only thing not on that same level is the 25R, so bring that down as a multiplier. So 25R equals the, times the ln of E, and then the ln of 4 remains over here. Remind yourself, what did we learn about the ln of E? It's basically saying, what's the exponent on the number E if I'm in base E? So that turns into that fancy 1. So that even makes it easier. We want to solve for r here. So if we're solving for r, go ahead and divide by 25, because 25 times 1 just gives me, or 25 times r. So we're going to end up with, let's move this up again, a division left over. And so r equals, do that division, ln of 4 divided by 25. I don't think my answer's gone. If we move the money, did you get about 5.5%? Remember, your calculator is going to give you a decimal, and you must move it 2 places to the right to turn it back to a percent. And it is, of course, probably rounded a little. So, anything else? Nope. Mr. Croc's going to do it. So let's go back and check and bring any questions you have, because that should do it for new topics.